Hello, because chapter 3 or 4 in your book, no, I can't remember which chapter it is, talks about different algorithms for the whole numbers. I want to share some thoughts about algorithms that are sort of supplementary to what your book talks about. So your book goes through the standard and, importantly, alternate algorithms for the 4 arithmetical functions of elementary arithmetic, of elementary mathematics. And we say arithmetic in elementary school, we specifically mean those 4 things. We mean addition, subtraction, multiplication, and division. So if you've ever wondered what is arithmetic, how does arithmetic relate to math? Arithmetic is one branch of mathematics, especially in elementary school, that used to be almost the sole branch in elementary school way back in the day, but today is an important branch, but just one branch, along with things like algebraic thinking and geometry and measurement. But arithmetic, addition, subtraction, multiplication, division, is still really the core of elementary math instruction. Part of that instruction eventually involves using algorithms for certain arithmetical functions, such as adding, subtracting, multiplying, or dividing multi-digit numbers. Now, your book talks about numerous alternate algorithms. These are probably different than what you learned when you were in elementary school. Depends on where you went to school. I, because I'm old, never learned any of these when I was in elementary school. Why do we worry about them? They have several potential purposes that are useful for us. They can help students build an understanding of the arithmetic operations. Let's fix that. So, of the operations of arithmetic, of addition, subtraction, multiplication, division. They can help students who struggle with the standard algorithm. Many students, when they sort of talk about struggles in math, a lot of those struggles involve learning standard algorithms. They can also help, some of them at least, with some specific issues involving, for example, regrouping. They also have some potential disadvantages. They are often slower than what we call the standard algorithm. If we are forced to teach all, or not all, because there's more than we can reasonably teach. If we are forced to teach multiple alternate algorithms in our class, we are taking up valuable instructional time, and it is going to be more challenging to get through everything we need to get through. They are also frustrating students who are ready for the standard algorithm. You as potential teachers need to be familiar with alternate algorithms to be able to explain them as needed. And so in your homework, I've asked you to do a handful essentially of alternate algorithms for addition, for subtraction, for multiplication, and for division, depending on the homework assignment. There are others in your book. There are others that aren't in your book. Some are probably more useful than others, but some I think are very, very useful. I, for example, think I would have loved lattice multiplication if I had been exposed to that in school. I think it would have made multiplication for me a lot easier. I think some of the alternate subtraction algorithms where we do things like we add digits, or we add numbers to the numbers we're subtracting to eliminate the need for regrouping are also really beneficial. And actually, those also really deepen some understanding of numbers. This is really preparing for algebra, because what we're saying there is you can do whatever you want to a number as long as you do it to all the numbers involved. So there's lots, I think, of good purposes for algorithms, but there are also some potential disadvantages. No matter what, the goal is the standard algorithm for addition, for subtraction, for multiplication, and eventually for division. But alternate algorithms might consistently be needed accommodations or supports for some of your students. No matter what you end up doing with alternate algorithms in your future classrooms, it's important for students when they get to the standard algorithm, as they go through it, for them to understand what's going on and not just follow the steps mindlessly. And so, for example, if you're teaching the standard algorithm for addition, you're almost certainly, let me rephrase this, you should definitely use manipulatives while you're teaching that algorithm. Now, eventually, students won't need the support of manipulatives, which is the goal. You want students to develop their understanding, not just to be able to mindlessly follow the steps. One of the most important things you can have students do in your math class is to write about math. This is why in my math class for you, for example, there are several times where I ask you to do something like to analyze what a student did wrong. This is why I have you write in discussion boards in every module. It's important to write about math, and it's important for your students to as well. So this helps them develop understanding, but it also helps you assess their understanding. I do want to point out specifically the long division algorithm. Most math educators believe that the standard long division algorithm is inappropriate for most elementary students. This essentially relates to their developmental readiness. The long division algorithm requires abstract thought. It requires students to be more at, if I don't know if you've taken developmental psychology or not, you will at some point take something like it. And in that we talk about Piaget, an important child psychologist who is controversial and rightly so, but there are some good points there. And Piaget talks about stages of development, and those stages aren't quite what he said they were. They don't occur quite the same times he said they were. But we go from concrete operational in typically in upper elementary to formal operational or abstract thought, typically in middle school and high school, probably more in high school. For some students, it may not occur until college. And it varies from subject to subject and other things. But that abstract thought that's needed is almost never present in an average 5th or 6th grader. And so the long division algorithm can be very frustrating. It requires abstract thought. It requires the ability to really mentally juggle multiple steps with arithmetic. This doesn't mean the long division algorithm shouldn't be taught, but 5th or 6th grade is probably too early for it. It is probably something that should be taught later in school, so students are more prepared for it, not in terms of their knowledge or their abilities, but in terms of their development. Now, that's not something you're going to have control over. In other words, if your curriculum says you're going to teach the long division algorithm in your 5th grade classroom or your 6th grade classroom, you of course are going to do that. But please recognize that it is typical for students to struggle with it because it is probably not something a typical student is ready for. That doesn't mean they can't learn it, but they often learn it just going through the steps and not understanding it. So keep that in mind. I do also want to mention some vocabulary. This comes through a lot when I do ask you to analyze a student's work sample. Try to avoid informal language and use mathematical language, and try to model this in your future classrooms. And the big thing with algorithms is that it's important to talk about regrouping rather than carrying or borrowing. Now, I am guilty of this. I will say carry, I will say borrow, because that is what I was taught when I was in elementary school. But carrying and borrowing aren't really mathematical terms, and they don't necessarily reinforce the place value nature that we need when we're working with standard algorithms especially. And so the better term to use is regrouping. And that's almost certainly the term that's going to be in your future curricula that you're teaching from. So I want to conclude this by reminding you it's really important for future teachers to learn the alternate algorithms. Again, there might be others that you'll be exposed to in your future curricula, but alternate algorithms can help students who need extra support. Again, they are often today part of the curriculum, particularly some of them. Some are more common than others. They are designed both as support for students who need it, but also as ways to really develop students' understanding of what's going on. I would also say that you eventually are going to be the judge of what is best for your students. And again, if you have a student who, for example, is highly gifted in math, going through alternate algorithms with them might not be worthwhile. Now, it might be as well, because to understand that, wait, we can do something more than one way is a really powerful piece of learning. Too often in math, people think that because math is associated with one right answer, that also means there's only one right way to get to the answer. And that's not true. Now, there are certainly wrong ways to get to the answer, and we need to caution about that. We need to make sure that students aren't developing bad habits. But there can be multiple right ways to get to the answer. So please take the alternate algorithms in your textbook seriously. Please take the time to work the examples and to check them as needed. I again am asking you to do several of them as homework assignments, and I will, with those homework assignments, typically give partial keys for the algorithm so you can see how they should ideally, quote unquote, ideally be laid out. It's important you write them large enough for your students to see, obviously on homework large enough for me to see. Be really cautious with things like lining things up correctly. That, by the way, this is a sort of a random thing, but students who struggle in math will often benefit from doing math on grid paper or graph paper rather than regular notebook paper, because it helps them line up place value columns more. And again, as someone who's himself struggled with math in elementary school, I think that probably would have helped me back in the day. I know that I got problems wrong because of how I lined things up, and I did not have good handwriting as a kid. I don't have great handwriting as an adult either. So that is a support or a scaffolding that can sometimes be used, just a different type of paper. So if you have a student who struggles with math and you think it's because they have trouble with lining stuff up, try graph or grid paper. So if you have questions, please let me know. Thanks for watching.